Today we're going to start learning about graphing linear equations in slope-intercept form. But first we have to go over a few different terms to help us with our vocabulary and to understand what's going on the graph. The very first term is talking about the X-intercept. The X-intercept is the point where the graph crosses the x-axis. The point where the graph crosses the x-axis. So when we graph our different graphs that we'll be using, that point is going to tell us the x-intercept. It's where it intercepts the x-axis. So when we do that mathematically, this is where we have, we can solve it through graphing, of course, but also we can plug in different variables or numbers in to help solve. When it touches the x-axis, your points on a graph will be our x variable and then 0 for y. So mathematically, if we were to solve by just using an equation without graphing, you would plug in 0 for y. And mathematically, you can find out what your x-intercept is. Now the opposite goes for the y-intercept. So the y-intercept is not the point where it crosses the x-axis, but it's the point where the graph crosses the y-axis. And we'll be using this one quite a lot as we are graphing through slope-intercept form. And again, mathematically, that's going to be, where when we have a point, we're going to have 0 in for x, and then we'll find out what our y coordinate is. So mathematically, we will plug in 0 for x. So let's say for a minute that we went ahead and graphed some kind of line, okay? So we've seen this a lot. We've graphed in different ways with t-charts up until this point, but say I graphed it right here. So this point right there, that's going to be the x-intercept because it's crossing the x-axis. Now let's pretend it's the point of 2, 0. So mathematically, I would have plugged in a 2 into my equation for y, just like we talked about, right? Y is going to be equal to 0. If I plugged it in mathematically, 2 would have been our answer for that point. And then the y-intercept is the opposite. So that's the point right here, the up and down on our y-axis, but that's going to be our y-intercept. And so the point, let's say it's also at the 2, but this time it's at 0, 2. So just like I talked about earlier, your x value is equal to 0. So in an equation, you can plug in 0 for x and mathematically find your y-intercept. Now I want to introduce slope-intercept form. Slope-intercept form is written as the form of y equals mx plus b. Now we have already used y equals mx. We've done that before with proportional relationships. So we already know that m is going to be our slope. Now we have something added on to the end of our equation. This plus b stands for your y-intercept. So that means whatever number is there is where the graph crosses that y-axis. So in this example, the b would equal 2 because we crossed the y-axis at a positive 2. Now let's get into some examples. We are going to find the slope and the y-intercept of the graph of each linear equation. It's pretty easy because they're all in the form, or mostly in the form, of slope-intercept form. So let's write slope-intercept form, y equals mx plus b. Remember that m talks about the slope, and then the number b is going to be the y-intercept. So once the equation is in the slope-intercept form where it's y equals mx plus b, we just have to rewrite the problem and explain what's the slope and what the y-intercept is. So let's talk about this first one. We are given y equals negative 4x minus 2. Well, it's right in y equals mx plus b form. Now let's talk about this. The number in front of x that's multiplying, well, that's your slope. So our slope is at negative 4. So what that means, we make it into a fraction of negative 4 over 1. If we were to graph, we would be going down 4 over 1 because it's a negative slope. Now we have to talk about the b, the y-intercept. The number that is after the x, we are going to claim as the y-intercept. So it's minus 2, which means the y-intercept is at negative 2. The point where it crosses the y-axis is at -2, 0, -2. So if I were to just sketch a graph out here, guys, so you can see what's going on, this is what tentatively this graph would look like. I would first start with my y-intercept. So I go 0, -2. Remember, y-intercept, this is the y-axis, so I go to -2 there. And then I just graph with my slope. I go down 4, I'm going to extend my axis, go down 4, then over 1. Or I could do the opposite. I can go up 4, 1, 2, 3, 4, and over the other way 1, and then we draw our line. And that's how you do it. And the next example, it's a little silly because we don't have it in y equals mx plus b form. Y should be by itself, so y equals mx plus b. Y is not alone. We have this -5 that's kind of disrupting it. So what we do now is we have to move the 5 to the other side. I do opposite operations by adding it to the other side. When I do that, the 5 cancels out and I'm left with y equals 3/2 x plus 5. 5 and 3/2 x are not like terms, so it comes to the after. Now it's in slope-intercept form. Our slope is always the number in front of x, so our slope is 3/2. And then our y-intercept is always the number that's after the x. So our y-intercept is at +5, which is really the point of 0, 5 on the graph. Go ahead and try to find the slope and the y-intercept of this very last equation. It's already in slope-intercept form, so use that first example to help out with trying to find out what your slope is and what your y-intercept is. Pause the video and then come back to check your answer. Your answer for your slope is 5, so if you were to graph it, you'd go rise 5 over 1. Your y-intercept is -1 because it says -1, so the point on the graph that it would start at would be 0, -1. Go ahead and try these 3 problems as well. The second and third problem on your page are exactly like the second problem we did together. The problem is they are not in slope-intercept form. They need to be in y equals mx plus b form, so you'll have to move the +2 and the -1 to the other side. Use our second example from the video to figure out what to do. Pause the video, and then when you come back, check your answers to see if your slope and y-intercept are correct. Here are the answers for the 3 y-intercept, slope-intercept forms. On number 1, it was already in slope-intercept, pretty simple. We just pulled out the 3 from in front of the x, and 7 was negative, so we crossed the point at 0, -7. For the next 2, just as I said, we had to move some things around. So in the second equation, I had to subtract the 2 to the other side of this equation, so now it is a -2 for our y-intercept. It was the opposite for the third equation. We had a -1, so I had to add it to the other side to make sure that it was the opposite. So the y-intercept crossed at 0, +1. Make sure your answers are correct, and if you have any questions, make sure you let me know. Now we're going to take these equations of slope-intercept form and actually graph them on an actual graph. So there's a couple steps here. Once we graph them, we do have to identify the x-intercept, but let's not worry about that right now. So the different steps to help you are pretty simple, okay? So the step 1 that we'll have to do is going to be find and graph your y-intercept. That's going to be your first part, okay? And remember, that is b in the equation of y equals mx plus b. So let's do that first, and then I'll tell you what's up for the next one, okay? So for this first example, we have y equals -3x plus 3. Now remember, we just figured out how to find your y-intercept and your slope. So let's kind of pick that out first. So first, we have our slope of -3, and then we have our y-intercept of +3. Now, as I've been writing y-intercept, we've been actually writing it as a point at 0, 3, right? So for step 1, it said, find and graph your y-intercept. So Our y-intercept is 0, 3, so that's what we're doing. We go to 0, 3, and put our point. So I did that in purple. Great. Now, let's talk about what your step 2 is. The step 2 is from the y-intercept, we are going to graph the slope. So when we do that, we're going to just count our rise over run. So if our slope was -3 like we wrote, we have to make it into a fraction of -3 over 1. Because it's negative, the rise is going to go down and the run's going to go to the right. You can also do the opposite, and I'll show you on the graph, but you can go up and then to the left to continue the line. So we start at the y-intercept and we count down 3 over 1 and put your point. Then from that point you go down 3 over 1 and then down 3 over 1. So we put a few points there. Great. But I ran out of space on the graph. So from the purple point, I'm going to do the opposite. I'm going to go up 3 and then to the left 1 like I drew my second set of arrows, and it continues the line. The last thing you do is connect your points right there. And that is how you graph using slope-intercept form. Now the last part of this problem says to identify the x-intercept. Well, this is our y-intercept, but the x-intercept is on the x-axis. So we just have to find the point that crosses it. Well, the point that is the x-intercept is 1, 0, and that's the x-intercept of this graph. Now let's do the next example. It says graph this equation of y equals -2/3 x minus 2 and identify the x-intercept. So the first thing I do, which we did previously, is we have to find and graph your y-intercept. So our y-intercept is that number that's after the x. It's -2. The point of the y-intercept is 0, -2. So I go ahead and graph it. On the y-axis, I go down to -2 and I plot my point. Step 2 says, from the y-intercept, graph the slope. So let's find what our slope is. The slope is always the number in front of x. So our slope is -2 over 3. Now it's already as a fraction for our rise over run, but it is negative. So that means we go down 2 to the right 3. Or just like in the previous example, you do the opposite. Up 2 to the left 3. So let's do that. From our y-intercept, I'm going to go down 2 to the right 3. I'm going to do it again. Down 2 to the right 3. And then I ran out of room, so I'm going to do the opposite way. Starting from purple, I'm going to go up 2 to the left 3, and it continues that line that we see going on. The last thing we do, we just connect our line, or our dots. Goes all the way through. Don't forget about your x-intercept. The x-intercept is where it crosses the x-axis. That is the point of -4, 0. Go ahead and try the next one on your own. I will say that you have to draw a couple extra tabs on your graph, but try it yourself. Also find the x-intercept and then check back with the answer when you're done. Here is the graph for the third example. Our y-intercept is at -8, so I did have to draw 2 tick marks at the bottom of the graph. And then I went ahead and graphed my slope of 4, which really is up 4 over 1, up 4 over 1. It's a positive slope this time. When I graphed my points and then drew my black line through it, I identified the x-intercept at 2, 0. That's the point across the x-axis. Go ahead and try the next 3 on your own. It's the same as before, so use your previous examples for help. Then come back to see the answers. Here are the answers for the next 3 graphs. These are what your graph should look like. Make sure if it's a negative slope, you have a negative slope. Make sure your y-intercept is the first thing that you plotted. And also make sure that you found that x-intercept, the point where it crosses that x-axis.